Hi everybody, my name's Chris Collison and today I'm going to be presenting the first description of your actual lab procedure for the lab titled Thermochemistry to the Rescue. The important thing for this lab is treat your preparation with military precision. Know exactly what each member of your team is going to do before you step into lab. Get in, get it done, and get out. It's certainly a very well-functioning experiment. You'll use temperature probes that operate well. You'll have water available to you that's pre-stabilized at room temperature. So put in your preparation so that you know exactly what you're doing before you come to lab. There's also a pre-lab, so please make sure you take care of that pre-lab. But without further ado, let's jump into some of the details for part one of this experiment. So in this first part of the experiment, you're going to determine the specific heat capacity of the human hand. So you're actually going to measure the specific heat capacity of a Vienna sausage, and we're going to approximate that to a human finger. So when you first get into lab, you need to assemble your coffee cup calorimeter. You're going to add and weigh out, or measure out actually, in terms of volume, 100 milliliters of deionized water. This water will be placed in a large beaker for you to equilibrate before you come to the lab. So think about a lot of temperatures here in this particular experiment. For example, what's the temperature of the room? And why would we care about the temperature of the room? What's the temperature of the deionized tap water if you just take it out of the tap? And what would happen if these are different during the course of your experiment? If you're trying to get through this efficiently, then you don't want there to be a big disparity between the temperature of the tap water and the temperature of the room. So think about whether this matters to your experiment. And again, why are we adding that 1,000 milliliters of that liter of water to a flask? Well, again, we want to make sure that that water is pre-stabilized, that it's not fluctuating, it's not changing in temperature over the course of the experiment. So once you've built your coffee cup calorimeter, one of your team members also should be making an ice slush. We're making this ice slush so that we have a low temperature, stable position for the sausages to be placed. So we're going to call this a heat sink. So all of the heat from those sausages is going to be taken up by the ice. But we know that we're not going to go any lower than 0 degrees Celsius if we have a mixture of ice in water. So that's why that's important. So make sure you fill the beaker with ice. You will have ice on hand at the start of the experiment. Make sure you just have enough water to produce a slush. You want enough water to make thermal contact with the sausages, but no more. And basically press those Vienna sausages into that slush and keep them there for 5 minutes, and that will allow the heat from the sausages to have come out and for those to have equilibrated to 0 degrees Celsius. And think about describing why you need to do this in your lab report. So we're then going to assume that the sausage has the same specific heat capacity as that of a human finger and hand. And you'll see later in my Excel spreadsheet how to determine the specific heat capacity of those sausages. Step 3, you're going to measure the difference in temperature between the stable room temperature of the water and the lowest temperature that you measure of that water after you've put the sausage in it. So you'll note that the temperature is going to decrease and you'll want it to stabilize at a low value. Okay, so take readings every 5 to 10 seconds. This is where you need to be on. One of you is looking at the temperature. Every 5 to 10 seconds is reading off that temperature for your partner to write down. When you've finished, when you've got your low temperature reading, take the sausage out, dry that sausage because you don't want to weigh any of the water. You just want to weigh the sausage, and then go and take its mass. And of course, we've talked about this, and we'll think about this in the Excel spreadsheet that's to follow, but the heat of the sausage is equal to minus the heat of the water, and that's based on conservation of energy. We're also going to recognize that the final temperature of the sausage is equal to the final temperature of the water. So think about that. Then simply solve for the specific heat of the sausage, put the result on the board, and we're going to use this collectively for error analysis and standard deviations measurements within the group, and you'll use that for your final report. And then take new water from your volumetric flask, from your equilibrated water source, and so measure out that volume and go ahead and use the second sausage and repeat the experiment. So that's the first part. It should take you maybe 20 to 25 minutes to get this going. So make sure you are ready to go as soon as you step into lab. So be prepared. And part 2 is up next. Thanks for your attention.